Is that you or is that? That's you. Okay, cool. I like it.
All right. What's that first problem? Thanks, man. So what I want you to be able to do is to look at that and quickly identify what's in the wrong place. The 3's in the wrong place. Why is the 3 in the wrong place? Because it's with the freaking variables, not with the numbers, right? All right. So of course, what do we want to do? I want to get this to disappear. Right now it's adding, so what's the opposite of that? Subtracting. So basically when you're solving equations, you're always asking, what's happening? Let me do the opposite. What's happening? Let me do the opposite, because that's how you kill things. I also think of it as unburying the x. The x is buried under all this shit. Well, if I take 3 away, I've just taken 3 feet away. So now, oh, there he is. Trying to unbury that. I have no idea if that makes sense to you, but that's how I look at it sometimes. So if I subtract 3, I get 1 layer of shit out of there. X is much more by itself. It's still not by itself, but it's a lot closer to being by itself. Right? And over here I get... Yeah, we're not dividing by 3, we're subtracting 3, right? Okay, I like it. And now I want to divide by 2 because the operation here is multiply. So to break that bond, I divide. So I get x equals 3. How would I officially check that? Because I do ask you to check it, and that's often overlooked. In the homework, it asks you to check it. If you don't, I'm going to have you redo it. Oh, shit. Yeah, plug it in. So if I want to check this, check yourself. I'll put in there 2 times x plus 3 equals 9. And x is supposedly 3. 2 times 3 is 6 plus 3 is check. That's all it is. You're just making sure. So when you solve an equation, you really are saying, okay, when this statement is true, then this statement is true. When this is true, then this is true. And that's how you check it. You make that true and you see if it comes out right. So that explains actually part E. If you got to part E, you're like, what the shit do I do with this? Hopefully that helps explain a little bit. What about the second one? I guess it's part B, Jeff. Oh my gosh. Keep the batteries. We spare no expense. We steal towels from hotels. B. What was B? B was...
2x minus 5.
22? Yeah. Okay. All right, so what do you do first here? Distribute. That is one that works better. Holy shit. Let's see. All right, well, crap. Let's see what happens. Let's see, all right. 4x. Careful, minus 10. Sorry, 37. Multiplying when we distribute. Okay. Add 10. So you see how I can see this becomes this. There's the equal sign. It's 22 still there. Add 10. The 4x is there. These cancel. The equal sign comes down. The answer on this side is there. I mean, that's a huge part of this. If you don't do that for yourself, you're going to make really silly mistakes where things just kind of go to the other side by themselves. They're just kind of wandering around like, you know, like John Travolta. Seriously. No? Okay. And then the last thing I do here is divide by 4. So you get x is 8. And if you check this, so again, you just rewrite the problem, but in place of x, you put 8. Supposed answer, yeah. So what do I do first here? Now, you don't have to distribute, right? Because why did I have to distribute here? This is really good. In fact, I didn't even think about this. Why does distribution work? Again, it's another one of those, like, I don't know if I want you to show me, man, but why does it work? So real quick, just go, sorry. Just side note. Why does distribution work? Well, what does twice something mean? Like, what does 2x really mean? Don't use the idea of multiplication. Be more basic. What does 2x really mean? 2x is doing what to each other? No, that would be x squared. Add it. Isn't 2x x plus x? You leave those x's alone. You like to check. It's fine. My ex can do whatever she wants to. Or whoever. Now, so 2 anything is that thing added to itself. That's the basic definition of what a 2 coefficient means, right? So what is this really? How can I rewrite this then? It's 2 of these, one of them plus another one. Right? Because what would order operations say here? Do the inside first. Can you? No. So what do you do then? If you can't use order operations directly, is you try to rewrite the problem using some other idea. So twice something is that thing added to itself, and now I can just do 2x and 2x, minus 5, minus 5. Now please, again, I'm not saying you suddenly have to do this like this. I am not. I'm showing you why distribution works. Please still frickin' distribute. Don't do this and complain, this my teacher makes me do. No. Especially if there was a 20 out here. Don't write 20, 2x minus 5. Dear God. Right, so that's why that step works. But here, do I have to distribute? What should I really do? Do I have to distribute? No, because I can do the inside. 16 minus 5 is 11. 2 times 11 is check. Alright. And then let's see. What's next? What was part C? It's a little more interesting, right? Thanks, man. Close. Yummy. So your focus should be where? Where are you always kind of drawn to? Parentheses, because that's where you want to distribute. I saw one person, I'm not picking on anybody. I'm not going to say who you are. They said, isn't that 8? I'm like, yeah, 3 plus 5 would be 8, but it's saying 3 plus 5. This is 3 plus I don't know. So we distribute, so then we're able to work with the parts. So after I distribute, I can add 3 and 10 all day long. But this is 3 plus I don't know yet. So here I get 3 plus 10, like I said. 5x. Minus 4 is still there, so everything kind of just drops down. The answer to this is here. Now 3 plus 10, 13 minus 4. Just trying to do a few things at once, is that right? 9. And now you can see the x's already have a side, so we just got to get the numbers on their side. So I see somebody who showed me their work, they had lost a negative or something, I can't remember who it was. But what do I do next here? What's in the wrong place? 9 is in the wrong place because it's with the x's. It should be over there with the numbers. That always sounds so like, I don't know, bad, but oh well. We got to do it. Negative 6 minus 9, negative 15. And then, of course, the last step. Divide by negative 5. So all the negatives cancel. X equals 3. So we got the right answer, but they had lost a negative. That thing was wrong. And again, to check it, you would throw a 3 in there. All right, interest of time, I'm just going to keep going. What about D? It's kind of longer, right? Oh, yeah. What was it? So again, if you distribute first, you got all these parts, you can put your like terms together. So distribute first, like terms next, get the x's on one side, the numbers on the other side. You start to realize there's kind of this pattern to it. Now we will learn during the semester how to do even more complicated equations with like variables underneath in the denominator. Things with radicals in even the square roots and shit in the equation, right? But the same basic ideas will still apply. Do the opposite operation to get things that you can work with. So here, first thing of course I do is distribute. I'm really in love with 10 on this whole thing. When you distribute the negative 2, you got to be careful. Negative 2x Plus 14, yeah. One of the easiest places to make a mistake. And now you just get your like terms. Now this is a cleanup time. Get your like terms together. What happens here? 9. And over there,
18.
yeah, 18. I'm with you.
X.
X minus 2x is negative x. Cool. The bigger one's negative, so the answer's going to be negative. Yes?
When we're writing these out for homework and quiz purposes, if we're combining like terms, are you cool with just doing that? Kind of like underlining.
Yeah, totally. Yeah, there's no need to like
the minus.
move them around and all that kind of shit. That's fine. Yeah. Oh, by the way, this might be sort of what you're talking about. Can somebody tell me if on this, I'm sorry, if on this step I would have done this, can anyone tell me why that is so desperately wrong?
Because it's on the same side.
On the same side. What did it do to this side? I added 8. And the other side didn't change. You only do this kind of thing to two sides of an equation to keep it balanced. It's like adding 8 pounds to one side of a scale and nothing to the other side. Is it going to still be balanced? No. Right? So over here, which way do you want to move the x's? What do you want to do?
Add x to those.
I would add 10x. Because if I add the bigger one, it doesn't matter, to be honest, but I just don't want to, if I don't have to bring a negative in, I won't. You guys with me? It won't change the answer at all if you take it the other way. I just don't make it negative. I'm not going to make a negative mistake then. It doesn't matter. You guys with me? It doesn't matter which way you go. So I get 9 equals 18 plus 9x, because the bigger one's positive. Subtract 18. Negative 9 equals 9x. Divide by 9. X equals negative 1. And then we check. Shit, so it's about time. So very, very, very quickly, that last one, just in case you look at it, because it does come out kind of weird. And I love how you guys hate X. You're like, why did they do that? And then when X is about to die, you try to save its life. It's hilarious. Just let it die. So what I mean, on this problem, if you did this problem, the X's should have all died. But you guys are so funny. Well, X, no. Let me see. Where's it? Sorry, I'm a lot. You have to apologize me. I'm stealing your sheet. It's my sheet. It's my sheet. Oh shit! Alright. I'm going to go through this just a little bit quickly. Right, first you distribute. Then you get your like terms together. Looks like that's x, right? Plus 8 equals, 17 plus x. Yes, this looks familiar. If this was 2x, what would you do? X's, right? What would you do to the x's? You would subtract x, right? It doesn't. So why would these don't tell you what to do? We're the humans. We tell the freaking problem what to do. Shut up, problem. So I got to get my x's together. Well, what does that mean happens? They cancel. Don't save it. Don't go, oh, x. No, let it die. So remember, the right way to look at the end of a problem, of a solving problem, is when this is true, then this is true. When is 8 equals 17? Never. So when is this problem true? Never. So no solution. A really easy example about why that could happen. What number is the same as if you add 1 to it? What number stays the same when you add 1 to it? That's what that equation says. You guys see that?
Yeah.
What number is the same as if you add 1 to it? Is there any freaking number that does that shit? If you add 1 to a number, it's 1 bigger than it used to be. So if you solve this, there should be no freaking solution. Of course, we know going in is bogus. Did I know going in this was bogus? Holy shit, it's too much. So it will end up here, and you just have to interpret it. Don't circle this shit. Don't say 8 is 17, Jeff. I approve it. No.
Okay.
So we'll do the field trip tomorrow. I'll probably bring, if I remember, somebody emailed me, maybe remind me, I can bring an answer key for that side, all the worked out stuff, so you can have it to reference. And we'll do the other side tomorrow. What's up? Oh, sorry. I heard the name.
There's the Waller. Yep.
I actually put password like 2 weeks ago, and so I wasn't. And I looked yesterday, but I wasn't inside of the Canvas.
I don't really use Canvas.
Okay.
What's your name? Are you enrolled?
Yeah, I'm on there.
Okay, okay. I don't use Canvas. So,
Okay.
yeah. If you love it, I'm sorry.
No,
I hate
thank
it.
you,
So.
thank you.
Okay, sure.